Hello everyone. In this video, I want to show you what is a linear approximation. Linear approximation is also called tangent line approximation. So what does it mean? Is we use a straight line to approximate the graph of a function. To use a straight line to approximate the graph of a function. This is what does linear approximation mean. Here we have an example. We want to estimate the function value square root of 4.5 without using calculator. Here is the function fx. Fx is the square root of x, and the graph is the red one. We know that we are not able to find out what does this equal if we don't have calculator, right? So I will need to set up a straight line and then use the function value of that straight line when x equals 4.5 to approximate this number. So how do I set up this straight line? First, I choose a point x equals 4. There are two reasons why I choose this point. The first reason is 4 is close to 4.5. Now this is very important. When you use a linear approximation, you wanna choose a point which is not far away from your target point. So now here the target point is x equals 4.5. So that's why I don't choose x equals 9 or x equals 1. Now the second reason I choose 4 is because when x equals 4, we can find out the function value f of 4 very easily. So 4 is an easy point. We call 4 as an easy point. Okay. Now, then on the graph of the function fx, we can find this point 4, 2. At this 4, 2, I draw a tangent line, okay, and I call this tangent line as Lx. Now you can see after I draw this tangent line, when x equals 4.5, the function value of Lx at 4.5 will be very close to the function value of fx at 4.5. Because these two points from this graph, we can see they almost overlap, right? So this tells me the L of 4.5 will be a very good approximation to the function value f of 4.5, which is the square root of 4.5. Remember here, we're not finding the real value of we're not finding the actual value of square root of 4.5. We only find a good approximation. Okay. So now the question is how can I know the equation of this straight line? Okay, to find the equation of this straight line, because Lx, we said it is a tangent line of the point 4, 2, right? That's why this method is also called tangent line approximation. So let's recall in the chapter 1 how did we find the equation of a tangent line. So first, we need to know what is the slope of this tangent line. Because if we can know the slope, then we can use the formula point slope form to find the equation of this straight line. Now in calculus, when we study derivative, we know that the slope of this tangent line at the point x1, y1, the slope equals the derivative of this function, the derivative of this curve fx when x equals x1. So therefore, the equation of this tangent line we can write as y minus y1 equals the derivative f prime of x1 times x minus 1. Now here we're going to use this formula to find the equation of Lx. Because this point is a 4, 2, and the function fx is square root of x. Let me erase this. So the step 1 is to know what is the derivative of the function. Because the square root of x we can write as x to the power of 1 over 2. So the derivative is 1 over 2 times x to the power of negative 1 over 2, which is 1 over 2 times the square root of x. Once we find the derivative function, in step 2, we substitute. Remember, we substitute 4, the easy point, because right now we draw the tangent line at the point 4, 2. So here you don't want to substitute 4.5 into the derivative function. You want to substitute 4 into the derivative function. By doing this, we can find the slope of this tangent line, which is 1 over 4. Okay, now in step 3, using the point slope form, we can find the equation of Lx of this straight line, which is y minus 2 equals 1 over 4 times x minus 4. Okay, and let's simplify this equation a little bit, so we can get y equals 1 over 4x minus 1 and plus 2. So we find the equation, we find the function of Lx is 1 over 4x plus 1. Now, in the final step, in the last step, we evaluate the function Lx when x equals 4.5. When x equals 4.5, that is 1 over 4 times 4.5 plus 1. Now 4.5 divided by 4. That is 1.125. So L of 4.5 equals 2.125. So 2.125 is an approximation to this value, the square root of 4.5. So the square root of 4.5 is around 2.125. Again, we said we're not finding the actual value of the square root of 4.5. Here, what we find is just an approximation. Okay, it's just an approximation. So let's go here. So Lx, we said is 1 over 4x plus 1. So when x equals 4.5, L 4.5. You can see from here, these 2 points are very close, right? This the purple one is the actual result, is the actual value of square root of 4.5, and this red one is the approximation, is L of 4.5. From this graph, we can see that they are pretty close, right? Okay, now let's take a look at another example. Here we wanna use the straight line Lx to estimate the square root of 9.1. Now this time we don't want to use the same equation. Why? Because if we use the same equation, we just find now this is the point. This is the point when x equals 9.1, but the actual result is this. The actual result is this. We can see that the difference is pretty big, right? So in this problem, we want to set up a different straight line, and this time the point we want to use is 9 when x equals 9. Because why? Because 9 is close to 9.1, and the second reason is we know what does square root of 9 equal. So in this time, I'm gonna start with a new straight line. So when x equals 9, f of 9 is 3, right? Okay. Now this time I will draw a tangent line at this point, 9, 3. The slope of that tangent line is f prime of 9, which is 1 over 2 times the square root of 9, which is 1 over 2 times 3, which is 1 over 6. So the equation is y minus 3 equals 1 over 6 times x minus 9, which is y equals 1 over 6x y minus 3 equals 1 over 6x minus 9 over 6. And 9 over 6, they have a common factor, which is 3. So we cancel it out. We have 3 over 2. So y equals 1 over 6x minus 3 over 2 plus 3. Now the equation is y equals 1 over 6x plus 3 over 2. So the linear function Lx is 1 over 6x plus 3 over 2. Now we can say when x equals 9.1, the function value f of 9.1 and L of 9.1 are very close. Right, you can see them pretty close. So therefore, this will guarantee that L of 9.1 will be a good approximation to the square root of 9.1. So to find what this value is, we plug in 9.1 into this linear function. One over 6 times 9.1 plus 3 over 2. 9.1 divided by 6. Okay, so it's around 1.52. And 1.52 plus 3 over 2, which is 1.5. So the square root of 9.1 is around to 3.02. Right? It's around 3.02. Okay. Now the difference between the approximation and the actual result, this difference is what we call error. The absolute value of this difference is what we call error. And if we use the error divided by the absolute value of the actual result, that is called the percent error. Like in the previous example, to find what is the error and the percent error, because the actual result of square root of 4.5 the actual result of square root of 4.5 is a 2.1213. If we keep 4 decimal places, and the approximation we got is 2.125. So this is what we call the real value, and 2.125 is our estimate value. So the error equals the absolute value of their difference. So the error is 0.0037. Okay, now for the percent error, the percent error equals the error divided by the real value, which is 2.1213, and multiplied by 100%. So the percent error is 0.1744.